Well, hello everyone. Welcome to Chapter 2, the basic trigonometry with the unit circle. I have sent you guys all the Unit 2 packet. It does have a book, the pages of a book inside of it, so it is going to look a little different, but feel free to read through the book pages that I've copied for you. Because I can't go to school and scan again, we're going to have to change our calendar just a little bit. Of course, this is an old calendar that I'm sending you. So it says that we have this on April 25th, but it's actually going to come out to you on April the 20th. That'll be the first one you'll get. You're going to get this page. It'll be book page 15, 1 through 27. It's page 9 in the packet. Okay, so you should be able to see that. I'll show you where it is in the packet once we get to that point. Okay, so I'll see what I can do about sending a new calendar, but because I put everything out on the Google Classroom, I pretty much have just been going along with that. So let me quickly get to what we're going to be doing in here. I'm going to break this one up a little bit because these notes are really long. These are the learning targets from Unit 2. I have put them in separate parts, so you'll see that there's a notes part, and then they're in this packet, which doesn't seem to be loading very straight. So there's a note part, and then there's a homework part behind it. So hopefully you'll be able to see both of those pretty soon as well. Okay. What we're looking at here, the basic angles in the rectangular coordinate system, we all should be very familiar with this. When we have two legs of a triangle, a right triangle that are the same, you know that they come into the ratio of t root 2. We called them x, and then x root 2. For the 30, 60, 90, we do need to know which one is the 30. So we're going to call this one the 30. This one will be the 60. And this one is the right angle. And this is where we had x, 2x, and x root 3. Just a different diagram for it on this particular set of notes, so that's okay. The Pythagorean theorem you should all be familiar with. It's a squared plus b squared is equal to c squared, and it is only used, of course, with a right triangle. Okay, so of course everything that we have been working on up to this point has been a right triangle. So I need to take a minute and just give you a few vocabulary words and terms. Feel free to look them up at a different place if you'd like to. There are lots of definitions and things out there that you are more than welcome to go get further explanations. Khan Academy is a great place to go. So the first thing I want to start with today is when we talk about angles, we need to talk about initial side and terminal side. So first of all, I need to, if I could see you in person, I would need for you to understand that when we draw an angle, we started on the initial side, and as far as we turn that angle and where it ends, where it starts is called the initial side. And then when we spin it or open it up, this would be called the terminal side. Okay, so all of our angles are also going to turn counterclockwise. Which means they are all going to spin in the opposite direction of our minute hand and our hour hand, all of those now. They are actually spinning in the opposite direction that an angle typically opens. So when we talk about the initial side of an angle, we are talking about the starting ray in standard position. Okay, so starting with the x-axis and then the end point, So when we talk about it, this is what we mean. Let's turn to a different color. Let's go with blue. So here's the endpoint, here's the ray. So when we talk about the position on the x-axis with an endpoint at the origin, this is the initial side of an angle, okay? So this is going to be called the initial, okay? Now, going back to where it ends, the terminal side, it is called the ending ray of a standard position angle. So when this angle is turned, so we open it up to be an angle, we'll say we'll open it up to here. So this is the initial side, and where the angle ends, this is called the terminal side. Okay, initial side, terminal side. The vertex, of course, you're going to recognize what that is. So the vertex is the common endpoint of the initial and terminal sides. Okay, you know where those are on every angle that we've done, where the vertex is. In this case, we're going to actually look for where the initial and the terminal sides actually have the same endpoint, and then we're going to call that the vertex. Now, what we're going to call it most of the time, it's just like how we use x so many times to name a variable. We're going to use what's called theta, and what that is it's just a Greek letter, and that is commonly used as a variable for an angle. Okay, so when we are talking about an unknown angle, we typically will call it theta. So our angles are measured in degrees at this point. And what that means is how many degrees has your angle opened up around the circle. So one complete rotation, so if I started initial side, I'm going to turn this to blue, and I rotated all the way around the circle and ended back at the same place I started, so initial and terminal were the same, then one complete rotation is going to be 360 degrees, which I'm sure that you already knew that now. But we're going to get into the particulars of this and the detail of what that actually means. All of these things that we're going to be looking at in our basic trigonometry and angles in the rectangular coordinate system are going to be measured starting on the x-axis and where they have moved around that particular coordinate. So when we talk about a unit circle, we're going to be talking about one little box inside of here. So that one square unit is where we're going to be working eventually. So right now we aren't. Right now we're going to just to continue to explain a few of these things, and then we'll go from there. So the rectangular coordinate system is also referred to as the Cartesian coordinate system. And the Cartesian coordinate system is where we find ourselves studying the angles. So the rectangular coordinate system connects the x-axis and the y-axis. All right, we name these in quadrants, and we always name them counterclockwise, just like everything else we do with our angles. This is quadrant 1. This is quadrant 2. And you'll notice that I'm naming them with Roman numerals. So please make sure that when we talk about the Roman numerals or what quadrant they're in, that we label these with Roman numerals. So quadrant 3, and then finally quadrant 4, Q4. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so the signs while we're in the quadrant. So if we're in quadrant 1, our X is a positive and our Y is a positive. I know that it seems like I'm giving you details of things, but please remember that these details are always true. Things that you have always known before are still true. So when you are doing the logical trigonometry, make sure that you are measuring whether both your X and your Y are both positive. If you're in quadrant number 2, you know that you would have a negative X and a positive Y. So your ordered pair would be a negative X and a positive Y. If we move to quadrant 3, if we move to quadrant 3, then I would be down here somewhere. I would have a negative X and a negative Y. And then finally, if I moved into quadrant 4, somewhere in here, I'm going to have a positive X and a negative Y. All right. Any questions that you have? As I look back over your notes, the only thing that I think maybe I should remind you, or just to give you a little more information on, and I'm going to change this to blue. You are not limited to 360 degrees. In other words, what if I started here? I'm going to start with purple this time. What if I started here with an initial side and I went around the circle twice? Well, then that would be 720 degrees. So if I continue to wrap around, or as many times as I've gone around the from initial to terminal, as many times as I've completed a rotation, that's 360 degrees per rotation. Okay? All right, we're going to stop here so I can upload this part of the video. I'm going to do this one, I think, in 3 parts just to allow the uploads to go a little faster. And I'll come back and work on this one in just a little bit. So we'll take a quick break right here.